Hey kids, this is Mr. Martin, and today we're going to talk about Chapter 3, Earth's Atmosphere. Earth's atmosphere is composed of gas, and this gas is denser the closer you get to Earth. Earth has gravity, and the gravity pulls the gas molecules towards the Earth, which is why the higher you go in the mountains, the more difficult it is to breathe because those gas molecules are further and further away. Well, this is true the higher you go. The higher you go, the less dense the atmosphere is. When you look at the atmosphere, we think of it in terms of oxygen because oxygen is the air that we need to breathe. It's the air that animals use and converts to carbon dioxide. But most of the air that we breathe is actually nitrogen. It's a blend of gases, but 78% is nitrogen and only 20.9% is oxygen. There's also carbon dioxide, argon, and then trace gases in our atmosphere. So when we look at the constant gases in the atmosphere, nitrogen is 78.08%, oxygen 20.9%, argon, neon, helium, and krypton, and then we have xenon, which is just a trace gas. So the bulk of our atmosphere is nitrogen and oxygen. We also have some gases that really affect our radiation budget. And if you remember from last chapter, we talked about sunlight coming in and then long wave radiation leaving. Well, our radiation budget is impacted by these different gases. For example, water vapor will also increase our radiation budget by trapping in heat. Carbon dioxide, which is from fossil fuels, volcanic eruptions, also increases our radiation budget. So we look at our increase in carbon dioxide, you'll hear a lot about greenhouse gas effect and the idea that the planet is warming. That is because with industrialization, we have increased over and over and over this carbon dioxide emissions into our planet, into our atmosphere, and at the same time seen an increase in the global temperatures. We also have an increase in chlorofluorocarbons. And what CFCs are is those are chemicals made for refrigeration equipment. Also, they were used for aerosols for a long time. And the reason CFCs are so bad is because when sunlight comes into the atmosphere and hits a CFC, it breaks it down and knocks off one chlorine atom. If you remember from a chemistry class, that chlorine atom comes along and finds an ozone atom, which is oxygen to the third. Okay, most oxygen is O2, ozone is O3. It's three oxygen atoms that are all combined. Well, the chlorine really likes the oxygen, the ozone atom, and it clips off one of the oxygen atoms and makes chlorine monoxide, which is chlorine with one oxygen atom, and then just regular old oxygen. So when chlorine from the knocked off CFC hits the ozone layer, it knocks off one of the chlorine molecules, and you have this chlorine monoxide and an oxygen molecule instead. Well, this bond is not very strong. So lo and behold, this little oxygen guy will go off into his loneliness, which keeps this chlorine guy back around who finds another ozone molecule, knocks it apart, then the oxygen leaves. So it's a cycle. So by the use of these CFCs over time, it actually created what we see is a larger hole. CFCs are actually like Pac-Man. They just eat and eat and eat and eat and eat up the ozone layer over Antarctica. So a lot of times you'll hear this, the ozone layer has a hole in it. It had a hole in 1980, as you can see, but in October 2015, it is significantly more pronounced and much larger because of the use of chlorofluorocarbons. Now, we have a lot of sources of natural pollutants as well. Volcanoes are pollutants, forest fires, plants can be pollutants because of the pollens and hydrocarbons they throw off. Decaying plants certainly can be. The soil, dust, and viruses can come up from the soil, and the ocean as well from salt spray and particulates. So there are natural pollutants that pollute our environment. You can see here are fires that occur naturally, and the smoke. Here is a volcano, which is a natural pollutant. But we also have a lot of pollution from other things, like our transportation system, where all of these cars and buses and trains and planes create a system that increases the pollution in our atmosphere. We also have industrial pollution with all of the power plants and farming and those things that increase our global gases that increase things like our global temperatures. Okay, one more thing that we'll talk about a little bit is acid rain. And what acid rain is a broad term referring to the mixture of rain that has higher than normal amounts of nitric and sulfuric acids. Basically what that is that with all of this pollution that's been put into the atmosphere, when it collects and rains, it actually has an acidic nature to it. Now, when you have acid rain, it doesn't like rot your hands off when you're out there walking around. But it does do some damage to forests, to aquatic animals, and those type of things. Now, one thing that's really good is acid rain is really from industrial pollution. And if you look from 1989 to 1991, you had some really large sulfate deposition, especially across Appalachia in the Appalachian Mountains. We've actually reversed that because of clean air technologies in manufacturing. And so we actually have a better, less acidic rain in America in 2011 2013 than we did in 89 to 91, which is great progress. A lot of that is because of the Clean Air Act, which was legislation to try to help with things like acid rain. They're very expensive to do because you have to make all sorts of changes to factories. You have to work with the transportation system, but you also, because of green technology and things, typically environmental legislation like the Clean Air Act does have a positive financial benefit over time. A lot of people argue about the benefits of Clean Air Act and legislation like this. That's not the purpose of this course. That's if you took a political science course and we're talking what side of the aisle you want to stand on. But for our purposes, we'll talk about the scientific inquiry of can we as humans impact the natural environment? And the answer is absolutely, in bad ways, like with pollution from transportation and industrial pollution, and in really good ways, like having some legislation to decrease the amount of acid rain. So we do have the power as a species to make tremendous difference in our natural environment. Okay, they also came up with the air quality index, and you'll see this every once in a while. And basically, we want good air quality index, which means that we have very little pollutants in the air, and there's little or no risk to people, and that's parts per million. If you look at moderate, you have more junk in it, unhealthy for sensitive groups, and then sometimes we'll get into the unhealthy, especially with the pollen in this part of the country. You'll sometimes see it's an orange or a red day, and that is because of the pollens as well as the industrial air pollution and other irritants in our air.